What's going on, friends? It is Rafi here today, and I'm gonna take a deep dive into the exact science behind how cancer forms at the cellular level. So if you want to understand what's really going on inside of your body, stick with me in this video. So what exactly happens inside of your cells before cancer even starts? So our bodies are made out of trillions of cells. Each has something inside of it in the center called a nucleus that holds something called DNA, which stands for deoxyribonucleic acid. It's basically the blueprint for everything the cell does. Now, normally, cells grow, they divide, and die in a controlled cycle called the cell cycle, which has strict checkpoints to make sure that everything is running smoothly. So, let's talk a little bit about DNA damage and mutation. So cancer usually begins, and this is the step one process. Cancer usually begins with damage to the DNA in one or more cells. This DNA damage can be caused by things like environmental toxins. You've got things like cigarette smoke, UV radiation, and chemical carcinogens. There's also radioactive oxygen species, which is noted as ROS, which are harmful byproducts of metabolism that can also damage our DNA. And then the third thing is that there are errors that can happen during DNA replication when cells divide. So when DNA gets damaged, the cell tries to repair that DNA using mechanisms like nucleotide excision repair. Then there is base excision repair, and then there's also something called mismatch repair. Now, while it's trying to do these things, sometimes the damage is just too severe, or the repair process itself actually fails. And when this happens, the cell accumulates mutations, which are basically changes in the DNA sequence that can affect some very critical genes. Now, cancer really arises when mutations affect specific genes controlling cell growth and death. So we have something called oncogenes, which are basically mutated versions of normal genes called proto-oncogenes that, when activated, push the cell to divide uncontrollably. Think of them as the gas pedal stuck to the floor. Examples include RAS and MYC genes. You also have something called tumor suppressor genes, which normally act like brakes, slowing down or stopping cell division and repairing DNA damage. When these genes are mutated or lost, like the TP53, which codes for p53 protein, or RB1, the brakes basically fail. The most famous tumor suppressor is p53, which is also known as guardian of the genome. p53 senses DNA damage and can either pause the cell cycle to allow repair, or to trigger cell death if the damage is too much. Step 3, the cell cycle dysregulation. So cells progress through phases. You've got G1 phase, which is basically cell growth. You have the S phase, which is basically DNA replication. Then you have G2 phase, which is basically preparation for division. And you have something called M phase, which is basically mitosis, which is the actual cell division itself. So normally, checkpoints ensure damaged DNA is repaired before moving forward. But mutations in oncogenes and tumor suppressors disrupt these checkpoints. So cells with damaged DNA continue to divide, propagating mutations. So what's the step 4? Step 4 is avoiding apoptosis, which is basically programmed cell death. Apoptosis is a process where damaged or dangerous cells basically self-destruct. So in healthy cells, if damage is irreparable, apoptosis kicks in to prevent problems. Cancer cells often develop ways to evade apoptosis by mutating genes that regulate this process, like overexpressing BCL2, which is basically an anti-apoptotic protein. And so this allows mutated cells to survive when they should actually be dying. Fifth step, which is basically sustained angiogenesis and tissue invasion. So to grow beyond a tiny size, tumors need nutrients and oxygen. Now, cancer cells secrete vascular endothelial growth factor, which is also known as VEGF, to stimulate new blood vessel formation, which is a process called angiogenesis. They also gain the ability to invade neighboring tissues and in some cases spread to distant organs.